Okay, so this is a review of how to work with complex numbers. This first question is a multiplication, and we're multiplying two binomials, two numbers, complex numbers that are in what we call A plus BI form. And they asked us to give the answer also in A plus BI form. So we do regular FOIL. 7 times 2 is 14. Outer is 7 times 3i, which is 21i. Inner is negative 5i times 2, which is negative 10i. And finally, last is negative 5i times positive 3i, which gives us negative 15i squared. Don't forget, it's I squared, which becomes a negative 1. Anytime we come across an I squared, we replace it with negative 1. And that means that what we really have is negative 15 times negative 1 for this last term, which gives us a positive 50. So now we combine the like terms. The 14 and the 15 are like terms. When we add them, we get 29. And the 21i minus the 10i can be combined to positive 11i. And this would be your answer in what we call A plus BI form. Again, only if we're told that we can work with these imaginary numbers, or we're giving the instructions, give your answer in A plus BI form, that's informing you that you're working with complex numbers. Otherwise, the types of numbers we use don't involve this I, which is, don't forget, the I equals the square root of negative 1. It's that new number that we've added to make go from the real number system into what we call the complex number system. Okay, so that was question number 1. Question number 2, this was a multiplication, and this is a division. We have a fraction, and again, it might say simplify, it might say rationalize the denominator, it might just say give your answer in A plus BI form, it might say divide. Whatever it is, whenever you see a fraction that has either an I in the denominator or a radical in the denominator, you have to do rationalizing of the denominator. You have to have the only types of numbers we want to leave in the denominators are just regular whole numbers, no i's, no radicals, anything like that. And the way we do that is when the denominator is a binomial, we multiply by what's called the conjugate of the binomial. This is 2 plus 7i, so what we're going to multiply by is 2 minus 7i. Of course, whatever we do in the denominator, we're going to have to do the exact same thing to the numerator. So I'm multiplying this fraction by 2 minus 7i over 2 minus 7i. Essentially, I'm multiplying it by 1, so that does not change the value. You can't hear me. Oh, okay. Because everybody else can hear me, right?
Yes, I can hear you.
Okay. Because somebody just texted me that she can't hear me. Okay. Now, you know, I always like to do the bottom part first. It's really the easier one. And when I do it, I'll see for sure what my rationalized denominator is going to be. Remember, conjugates, you just have to multiply the first numbers and the last numbers. So multiplying the first numbers, 2 times 2 gives me 4. And the last numbers, the 7i times a negative 7i gives us negative 49i squared. And again, we have this I squared, which is negative 1. So this really becomes 4 plus 49 as our denominator, which gives me a denominator equal to 53. 49 plus 4 is 53. So that's why this is called rationalizing the denominator. We end up with a denominator, no radicals in it, no i's in it, nothing, just a plain, regular, old-fashioned number. Of course, we still have to multiply the numerators together, and therefore I have to do FOIL because this is two terms and this is two terms. So doing FOIL in the numerator, and I have to do the whole FOIL because these are not conjugates. I get 3 times 2, which is 6. Then I do outer, which is 3 times negative 7i, which is minus 21i. Inner is negative 5i times 2, which is negative 10i. And finally, last is negative 5i times negative 7i, which is positive 35i squared. And again, I see this I squared, which I replace by negative 1. So this becomes a negative 35, which gives me as my answer, I can combine the 6 and the negative 35. That gives me negative 29. And negative 21i and negative 10i gives me negative 31i. And this is all over 53. This is a perfectly good answer, but it's not what we call A plus BI form. Because A plus BI form is you have to have the A number separately and the B number separately. So we just separate this. We put each term separately over the denominator. So we get negative 29 over 53 minus 31i over 53. And that's your answer in what we call A plus BI form. And basically that's what we had covered on Tuesday. Okay, so I'd like to go on from here. I'm going to erase this now. And I'm going to, this is really the last part of chapter 6. We have now completed, since the midterm was on chapters 1 through 4. We have since done 2 chapters, chapters 5 and 6. And I have set up a test on chapters 5 and 6, that material on Delta Math. Your next test is on Delta Math. You will be able to see it first this afternoon. I think it should be open by 2 o'clock this afternoon. I gave as a due date next Thursday. Next Thursday is the 11th. So by next Thursday, if you want complete credit for that test, you must do it by next Thursday. I've allowed 45 minutes for the test. It's more than enough time. There are 10 questions. Each question you get actually 2 times to try it. So it's, I give you a little bit of a leeway by giving you 2 chances on each question. Again, make sure that you are completing the homeworks on Delta Math and that you're doing these tests. Again, this will be the second. It'll say test 2 for fall 2021. That is, it's a second test on Delta Math, which will mean that it's really the fourth test of the term, because this will be the second test on Delta Math, and we had a regular test on Blackboard and the midterm on Blackboard. So this, and it covers chapters 5 and 6, which is about the fractions and about the radicals and about the complex numbers, the numbers with eyes. Okay, so let's go on from there. When we let me just start this. Chapter 7, which is what we're starting today. Okay. Is called quadratic equations. Now you're going to say, hey, we did call quadratic equations before. This is not a new topic. This is something we've done in the past. And yes, you're right. We did talk about solving quadratic equations. We said we would recognize that the equation is a quadratic equation because it will have a square term in it, or will have x squared if your variable is x, or y squared. It will be what we call a second degree equation. It's not a linear equation. It doesn't have just plain x's. It has to have an x squared. And that we said what we do is get it equal to 0 and then factor it. So what we're going to be doing in chapter 7 is examining what happens, or how can we solve a problem that's a quadratic equation that you either find too difficult to factor, that you just, maybe you could be factored, but you can't figure it out, or alternatively, it's not factorable at all. Not every expression can be factored. So what if the quadratic equation can't be factored? Does that mean that we can't solve it? And the answer is no. What we're going to learn is 2 basic methods in solving quadratic equations. So the first method is a method that's called completing the square. The second method, I don't know if we'll get to it today, but we certainly will by next Tuesday, is a formula. It's called the quadratic formula. But today we're going to learn this method called completing the square. In order to learn this method, we have to sort of start with some preliminary work and work our way up to this method. So the first thing I want to talk about is, what if we have a very simple quadratic equation? What if I have an equation that looks like this? X squared equals 16. Now that's a really simple quadratic equation because it just has a plain x squared, but it's definitely a quadratic equation because it does have an x squared. But you could almost figure out the answer here by just looking at it. Because what it's saying is that I have this number x. My variable is x, I don't know what it is. But when I square it, it gives me 16. So it seems to make sense that my answer should be the square root of 16, which is 4. Except that's not the only answer. The answer could be -4 as well, because I know when I do 4 squared, I will get 4 times 4, which is 16. But also when I do -4 squared, I also get 16 because a negative times a negative gives me a positive. Yeah, I haven't taken attendance yet. So the question is, which is the right answer? But you know, in quadratic equations, when we have these, we most often do get 2 answers. In other words, the solution here is 4 and -4. Those are 2 solutions. Sometimes this is written this way, x equals. So sometimes this is written in shorthand with a plus over a minus. That means either your answer could be positive or your answer could be negative. So this is saying the exact same thing as this. So there's this new symbol. It's just, if you don't want to, let's say your type, well, if you have this on your typewriter, that's very nice, because then you only have to write the 4 once, you don't have to write it twice. So I can now come up with a method of solving this kind of quadratic equation without going to factoring. All I have to do is, if you think about it, if I have something like x squared equals some number, doesn't matter what the number is, the x is then going to be either the positive or negative of the square root of that number. In other words, if we got x squared equals 16, then x was the square root plus or minus the square root of 16, which is 4. And that's when we have what we call a incomplete quadratic equation, where we have a quadratic equation where the only type of term we have is an x squared. We don't have any plain x term in it at all. I'll show you how we could do this a little bit more complicated example. Let's say I have a question that looks like this. Suppose I have y squared, using a different letter, plus 9 equals 0. Now, I recognize this as a quadratic equation because it has a square in it. I also recognize it as one of those incomplete quadratic equations where all I have is a y squared. So what I can do is get y squared, get the number, the y squared on one side, the number on the other side, just like we've always been doing with just plain y. So we get y squared equals -9. In other words, we're not solving right away for the variable, we're solving for the variable squared. We're solving for y squared. Because I know then the next step I can take is to take the square root, the positive and negative square root of that number. So once I get the variable squared alone, my next step is to get my 2 answers by taking the square root. And if I can simplify, of course, I'm going to simplify. Now notice what turned out in my square root was a -9. Can I find the square root of -9? Well, we just learned that when you have the square root of -9, you could really write it as the square root of 9 times the square root of -1, and the square root of 9 is 3. And don't forget, the square root of -1 is I. In other words, my y turns out to be plus or minus 3i. If I look at my original example, I couldn't factor it because this is not the difference of squares. This is just, there's a plus here. It's not y squared minus 9. It couldn't be factored. But in any case, we were able to solve it by this method that's called the square root method. Okay. What if I have something that looks like this? Suppose I have 4x squared minus 45 equals 0. I'm going to solve this one and then the next one you're going to do. Now again, it's this incomplete quadratic equation. And I always go to the square root method when I have it because it's really the quicker method. I'm going to solve for x squared. So I'll first add 45 to both sides, which will give me 4x squared equals 45. And then I want to get the x squared alone, so I'll divide both sides by 4, so that I end up with x squared equaling 45 over 4. So my first step is to figure out what is x squared. Once I know what x squared is, I then go to finish this by doing the square root. X will have to be, and don't forget to put in this plus or minus because there's always going to be two answers, the square root of 45 over 4. So once you've gotten the x squared, you're one step further gets you to the x. The only thing is that usually you're asked to put your answers in simplest form. So let's see how we could do that. Don't forget that plus minus means there are two answers, plus the positive answer and the negative answer. Remember, when you have a fraction, you take the numerator over the square root of 45 over the square root of 4. And we're going to simplify. Certainly the square root of 4, the denominator, is easy to simplify. It's 2. Remember, if it wouldn't be 8, if you couldn't take its square root, you would have to rationalize that denominator. But it turns out you can just take the square root of 4, which is a rational number. The 45 I can break up into the square root of 9 and the square root of 5, because 9 is a perfect square. And the square root of 9 becomes 3. So that my final answer in this case becomes 3 plus or minus, and I better not forget that, 3 square root of 5 over 2. There's no way I would have been able to get to this answer without this method, because I couldn't do it by factoring. So number one, we figured out a way of solving a quadratic equation that's what we call a incomplete quadratic equation. Okay, I'm going to give you one to try while I take attendance, and then we're going to go on to some that are even a little bit more complicated. So I'm going to put an example on the board. And I'd like you to get your answer in simplest form. So here it is, 3x squared plus 12 equals 0. Solve that and get your answer in simplest form. I'm going to be taking attendance now. Jesus Antonio. Let's see, he's here. Jackson. Good morning. Tiffany. Kayla Brantley. Okay, Tashana sent me a text, she's here. Deanna, you here? Deanna, I know you're here. Wensley.
Okay.
Oh, I hear you now.
Yeah, I have to change from my laptop to my phone. I don't know what's going on with my laptop, but I
Oh.
can hear.
You can hear me, but can you see with that on that little phone?
Yeah, I have to like rotate the screen, but I can see.
Okay,
All right.
good. Wensley Charlemagne. Tatiana Collins. Good morning. Awa Diallo. Good morning. Ashay Douglas. Is Shay here? Eliana Este. Eliana, good morning. Emily Gomez. Anastasia Guerra. Zanabu Hamed. Ismail.
Here.
Good morning.
Morning.
Jaden Jackson. Ashiana. Anijah. Thomas John.
Yeah,
Good morning.
morning.
Paul LeBrun. Good.
Here, morning.
Ashley Murad. Angelica.
Here.
Hi, good morning.
Hi, good morning.
Tayon. Good morning. Akeem Richards. Hi, good morning. Craig Ricketts. Craig? Giovanni, I know you're here because came on so early. And Devin Lee, you're here. I know you're here because you came on early. Najay Waddell. Okay. All right, so let's go with this problem and see if we can solve it. Our Diablo already posted something, looks good to me, let's do it. So since it's, again, this incomplete quadratic equation, we're going to solve for x squared. Let's bring the 12 to the other side, which gives us 3x squared equals negative 12. And then let's divide by 3. So that gives us x squared equals negative 4. So we've got the x squared. So now we have one more step to do. We find the x by doing plus or minus the square root of this number, which is negative 4. And the only thing that's left to do is to see if we can simplify this radical. And of course, this is the square root of 4 times the square root of negative 1, which gives us 2i. So my final answer becomes plus or minus 2i. Notice we're getting answers. Sometimes they're not even real numbers, but we're able to solve it, first of all, because we now know what and how to get things in terms of I, number one. And number two, because we have this new method called the square root method. We can even go further on this. What if I had something that looked like this? What if I had an expression like this? 2x plus 5 squared equals 16. And I told you I wanted to solve this equation. Well, there's a very long process that we could use called remove the parentheses by doing FOIL on the 2x plus 5 times 2x plus 5. Get everything, they'll have an x squared term in it, so I'll know it's a quadratic equation. So I'll bring everything to one side and set it equal to 0. And then I'll have to factor it. But there is a really much quicker way of doing this, because I can use that square root method that I was just talking about, even in a case like this. This is not an x squared, it's a whole thing squared. But whatever, if this would have been an x squared, what I would have done is I would have said the x over here is plus or minus the square root of this. So let's do the same thing. Instead of it's just plain x squared, we'll take the whole 2x plus 5. We'll take the square root of both sides. This side will just be the 2x plus 5. On the other side, we'll get plus or minus the square root of 16. Just like when we had x squared equals 16, we did x is plus or minus the square root of 16. If we have a whole expression squared equal to 16, we can do the same thing. Of course, I want to try and simplify this then. So first of all, the 16 is obviously just 4. That's a real number. And what it means, when we say that 2x plus 5 equals plus or minus 4, really means that we have two answers. One answer being 2x plus 5 equaling just regular 4, positive 4. And one answer we get by saying that 2x plus 5 equaling negative 4. Remember, this is just a shorthand to, instead of writing the 4 twice, we can write it this way. And sometimes they don't use this plus or minus, they just do it separately. 2x plus 5 equals 4, 2x plus 5 equals negative 4, like we're doing over here. Notice we really can go further on this because these are just regular equations. If I bring the 5 over here to the other side, that'll give me 2x equals negative 1. And just divide by 2. And my answer comes out to what? Negative a half. Over here, I'll bring the 5 to the other side. And that'll give me 2x equals, well, now this is a negative 4, and negative 5 gives me negative 9. And now I've gotten both my answers. One answer, I'm going to put them in. Here are my two answers. Negative 1/2 and negative 9/2. I didn't have to remove parentheses. I didn't have to do any factoring. I could use the square root method to solve this equation. You think you can try one like this? Let me give you one to try. Suppose I gave you this example. X minus 2 squared equals negative 25. See if you can solve that. And I'm going to give you a couple minutes to try that. See if you can solve that. Okay, I see that we already have an answer. Let's see if we can work it out. It's again set up where we have something squared equaling a number. So we can use our square root method. And on this side, we'll just get the x minus 2. And on this side, we'll do plus or minus the square root of negative 25. And we first have to, of course, change the square root of negative 25 is the square root of 25 times the square root of negative 1, which is 5i. So in simpler form, we get x minus 2 equals plus or minus 5i. Now, I don't want to have x minus 2. I want to have x. So I'm going to bring this 2 to the other side. And this 2 can't be combined with a 5i because they're not like terms. So the best way to leave your answer is put this number that you bring over first. This becomes 2 plus or minus 5i. And we can leave our answer like this, or you could write it separately as 2 plus 5i as one answer, and 2 minus 5i as your other answer. So what we see is if this number on the other side is not a regular rational number when we take its square root, if we get an I in it or we get a radical, all we have to do is then bring this other number over and just put it in front and leave it like that. So that when we, after we got the 5i, our final answer was 2 plus or minus 5i. Or you could write it separately as 2 plus 5i and 2 minus 5i. Of course, you can't combine them because these have i's, these are not. This is a real number, this is an imaginary number. But even though my example would never have been able to be factors because I never get i's when I factor, I still can solve it. But you and I know that most likely when you're given a problem, it's not going to be set up so nicely for you. It's not going to be in this nice compact something squared equaling a number. So I'm going to show you how to actually get an example into that format. And that's actually what's called completing the square. So we have to do a little bit of preliminary work. And some of this I'm just going to remind you. Let's say we have an expression like x minus 5 squared. We have a binomial squared. Remember I talked about there being a quick way of doing it. Of course, you can do x minus 5 times x minus 5 and use FOIL. But when you have a binomial squared, there really is a pattern that you can follow. Obviously, your first term is going to be x squared. Your last term is going to be this negative 5 squared. In other words, positive 25. And the middle number is going to be, remember there has to be this has to give you a trinomial. The middle number is going to be these two things multiplied together, negative 5x doubled, which is negative 5x doubled is negative 10x. Double means multiplied by 2. You can prove it to yourself by actually putting x minus 5 times x minus 5. You will get x squared minus 10x plus 25. What if I were to give you x plus 7 squared? We could do the same thing. Our first term would be x squared. Our last term would be the 7 squared, which is 49. The middle term that I'm skipping, I get by just multiplying these two together. 7 times x is 7x, and doubling it, multiplying by 2, which gives me 14x. And that's true of any binomial squared. The first term, when you expand it into a trinomial, the first term is the first term squared. The middle term is these two numbers multiplied together and multiplied by 2. So 7x times 2, which is 14x. And the last term is the 49, which is the 7 squared. Okay, so let's see if you really understood this. Notice the relationship between the number in front of the x and the last number. The last number is, if you take its square root, you get 7. 7 times 2 is 14. Or vice versa. If I have, see this 14, I know that last number has to be half of that, which is 7 times itself, 49. Look at it over here. This middle number is -10. Then my last number has to be half of that, which is -5 times itself, which is +25. And on top of that, the binomial is x minus 5 squared. So let's see if you can do this little puzzle. Suppose I gave you x squared plus 16x. And then I put a blank. And I'm telling you I have a trinomial. I'm not telling you the last number of a trinomial. That is a perfect square. It's a perfect square binomial. How do you figure out what this number is? And also, what is the binomial? Really quite easy. The binomial is going to be x plus something with a square on the outside. The number that's going to go into the binomial is half of this number. Because how did we get that 16? By multiplying these two numbers together and then doubling it. So if I want to get back to this number, I have to take, divided by 2, I have to take half of it. Half of 16 is 8, and it's a positive 16, so this has to be a plus 8. So that's the number that I'm looking for as the binomial squared. But what would this number have been? Well, obviously that number is always this number squared. So that would have been 64. If I add 64 to this trinomial expression, to the two terms that I already had to get a trinomial, it will be the x plus 8, that times x plus 8. The binomial squared. And this is what's called completing the square, because I was missing a number and I filled it in. I completed it to make this into a binomial expression squared. Let's say I had something like this, x squared minus 12x. And again, we have to have something that's missing. And we want to make it into a perfect square binomial. So here's my binomial that's going to be squared. The first term is going to be x. The second term is going to be half of this number, which is -6, because this was a -12. And the number that I have to add to make this into a perfect square binomial is this -6 squared. -6 times -6 is positive 36. So finding the missing number and then figuring out the binomial square is really not too hard. Again, you could do it in either, you could first figure out this number, you could first figure out this number. I always like to find this number first because it's so easy to do, and then I just figure this one out from here. Now I want to show you how this can help us solve a quadratic equation. So let's say I have this example. And I'm going to show you this example, two methods. Suppose I gave you the example x squared plus 4x I'm going to first try it by our old method, and then I'm going to show you how we can use a new method, the completing the square method. The old method that we did previous to this is we saw that we had a quadratic equation because we had an x squared. It's not an incomplete quadratic because there is an x term as well. So therefore I have to get it equal to 0. So I'll subtract 12 from both sides. So that'll give me x squared plus 4x minus 12 equaling 0. And now I go and I factor this. Now, I'm going to show you the two methods because you can pick whichever method you like better. They'll both work and give you exactly the same answer. Well, you know how we're going to try factoring this using our AC method. Our AC is negative 12, which means when we're multiplying one positive number and one negative number. Our B is positive 4. So we're looking for two numbers that are going to multiply to negative 12, but when I combine them, will give me positive 4. One of them is going to have to be a positive number. One is going to have to be a negative number. Well, what multiplies to 12 could be either 12 and 1. Here are our choices. 12 times 1, 6 times 2, 3 times 4. And obviously the choice is the 6 and the 2, where we'll pick the 6 to be positive and the 2 to be negative. This is the old factoring that we've been doing all along. So this will give me my x squared. We'll write this as positive 6x minus 2x minus 12. And grouping, in my first group I have an x. So you do x times x plus 6. In my second group, I have a negative 2 common factor. So this gives me negative 2 times, again, x plus 6. So finally factored gives me x plus 6 times x minus 2. So I factored the trinomial to x plus 6 and x minus 2. And I remember, since this is a quadratic equation, I then separated to x plus 6 equal to 0 and x minus 2 equaling to 0. And this gives me as one answer x equals negative 6. And here when I bring this 2 to the other side, my other answer is x equals 2. And this is a method we've been using till now. Obviously, it was dependent on being able to factor once it was equal to 0, to factor the side that was not equal to 0. If you can factor it, after you factored it, you set each factor equal to 0, and you get your final answer. The answer turned out to be negative 6 and positive 2. So this is the method we've used until now. Now I'm gonna erase this. I left the answer on the board, but I want to show you another method. Another method that works when you can factor, but it also works even if you can't always factor. So let's go back to our original equation. The x squared plus 4x equaling 12. Now, the first thing is that when you're using this method called completing the square, you want only the x terms on the left side, and you want the plain numbers on the right side. So this is a little bit of a difference because when we have a quadratic equation, we want everything on one side equaling 0. But this method requires just the x terms, the x squared and the x, to be on the left side and the regular number on the other side. And if you notice, I actually left a space. I rewrote this, leaving a space over here. And the reason I'm doing that is because I want to do something called completing the square. What I'm going to do is I'm going to look at this x squared plus 4x and add a number here to make this side a trinomial that will be a perfect square number, a perfect square expression. And I know how to do that. First of all, here's it's going to end up, we just did that, right? The first term is going to be the x. The second term is going to be half of this number, so it's going to be plus 2. And the number that we should have added, and I'm going to do it in a red pen, I hope you'll be able to see it, is this number squared, 2 times 2, which is 4. If I had an additional 4 added to the x squared plus 4x, so that I have x squared plus 4x plus 4, that is the binomial x plus 2 squared. If you don't believe me, just do x plus 2 times x plus 2. Again, how did I get it? I took half of the coefficient of the x and multiplied it by itself to get this number. Half of 4 is 2, 2 times 2 is 4. Now, obviously, I added 4 to this side, but I have an equation. Whatever I do to one side, I've got to do the exact same thing to the other side. So I'm going to add 4 to this side as well. Now, let's see what happened. We know now this x squared plus 4x plus 4 is the x plus 2 squared. What do we have on the other side? Well, let's combine them. 12 plus 4 is 16. And now the format of the question is familiar. I have something squared equaling a number, so I can use my square root method. I can take the square root of both sides. On this side, when I take the square root, it just gives me what's inside the parentheses, the x plus 2. On the other side, I get plus or minus the square root of the number, or the square root of 16. Again, this number might not be a perfect square. I might only be able to simplify it. But whatever I can do with it, I do. In this case, I'm simplifying this to the square root of 16, which is 4. So my answer comes out to be x plus 2 equals plus or minus 4. And of course, I have to bring the 2 to the other side to get what x is. Remember, when you bring this number to the other side, always put it in the front. Your final answer becomes -2 plus or minus 4. But since these are just both regular numbers, there are no square roots there, there are no i's there, I can separate this so that one answer becomes -2 plus 4, which is positive 2. And the second answer is negative 2 minus 4. Remember, that's what this plus or minus says. It's just a shorthand to say, once you do it with a plus, once you do it with a minus. The negative 2 and the negative 4 give us negative 6. If you notice, I got exactly the same two answers, negative 6 and positive 2, using this method called completing the square. Which method do you like better? Well, a little bit, it depends. Do you like factoring? If you like factoring, then you might like the other method better. But if you don't like factoring, well, here's a method that doesn't require you to factor, but you still come out with the same answer. Okay, let's try another one like this. In this case, one that is not factorable. I'm going to do one more with you, and then you're going to try it on your own. So I'm going to erase this and do a different problem. And I'm telling you right away, this problem is not going to be factorable, so I'm not going to be able to use that first method. I have to use this method. X squared minus 2x plus 5 equals 0. Let's start out with this example. And I think you're going to see that it can't be factored because my AC would be 5. I need two numbers that would multiply to 5, but when you combine them, you get negative 2. And the only thing that multiplies to 5 is 5 and 1. And even if it's negative 5 and negative 1, it's not going to add up to negative 2. It's going to add up to negative 6. It's not factorable. So here's what we can do. Watch this method. We want to use the completing the square method. The first step is only the x terms on the left side. Any number has to be brought to the other side. So we have now x squared minus 2x. And remember, I'm leaving a space because I want to complete the square equaling negative 5. Okay, so now I want to figure out what number to add over here to make this binomial, this into a perfect square trinomial. Okay, it's going to be x. What number, what's the other number that's going to go in here? Obviously, the x goes in here. It's always half of this number. Negative 1 divided by 2, half of negative 1 is, I'm sorry, negative 2 divided by 2 is negative 1. Half of negative 2 is negative 1. So therefore, the missing number here is this negative 1 squared, which is negative 1 times negative 1, which is plus 1. The number you're adding is always going to be a positive number because you're always multiplying that number by itself. So it'll always turn out to be positive, even if the number in the parentheses is negative. Now, remember, I just added plus 1 over here. So I have to do the same thing over here. I have to add 1. It's an equation. I have to keep it balanced. I decide what I want to add here to make this into a trinomial that's a perfect square. Whatever I add over here, I add over here. So what are we left with on the other side? Well, we're left with negative 4 plus negative 5 plus 1, which is negative 4. And now I take the square root because I have a binomial squared. So I get x minus 1 on this side. And on this side, I get plus or minus the square root of -4. And I simplify that square root of -4 by breaking it up into square root of 4 and -1, which is plus or minus 2i. And to finish this, I'm just going to bring the +1 to both sides. Now I'm just skipping over here. So over here, I'm left with x. And over here, I'm adding 1. I'm getting 1 plus or minus 2i. And I can leave my answer. I don't have to go any further because I know even the 1 and the 2i are not like terms. This is a real number. This is an imaginary. They can't be combined. They're unlike radicals, if you want to call it. So you could just leave it. You could also write it separately. This is 1. So you can either write your answer 1 plus or minus 2i, or alternatively, you could write it separately, 1 plus 2i and 1 minus 2i. They mean the same thing. This is just the shorthand use of using that plus minus symbol. But notice this is not anything that would ever have been able to be solved without this new method that we have, because it would not be factorable. It's not a factorable example. Let me just tell you, there are limitations to this completing the square method. You can do it with more difficult problems, but if there's a number in front of the x squared, you're going to have to divide everything by that number. It depends on just having a plain x squared to start out with. If it's not, and you divide everything, you might end up with fractions. Once you have fractions, it gets much more difficult. You know, fractions are much more difficult. The other thing is, if the number in front of the x is not an even number, if it's not easily divisible by 2, again, if it would be like a 3, I'd get 3 over 2. Again, I'd be dealing with either fractions or decimal, and it would make the whole problem much more difficult. So next Tuesday, I'm going to show you what to do if you have that type of situation. I really only use completing the square when the x squared coefficient is 1. It's just the plain x squared. And the x coefficient is an even number, something that's easily divisible by 2. If not, I go to a different method that I'm going to show you again on Tuesday. I want to give you some time to try a problem on your own. So I'm going to erase this and give you a new problem to try. This is on the sheets that I made, on the weekly folder sheets that I just sent you. Y squared minus 12y minus 8 equals 0. Okay. I want you to solve this using the completing the square method. Notice the y squared coefficient is 1 and the number in front of the y is even. So you should be able to do it. I'm going to give you a few minutes to try it. Okay, I think we should try working on this together because I want to finish it up before we run out of time. Again, I said I wanted to do it by completing the square, but I don't even think that this is factorable. We're not even trying to factor it because, as I said, I want to use the method, which means I have to bring the 8 to the other side. Again, it's a quadratic equation. This is the only method of solving quadratic equation that requires you to have just the variables, the y squared and the negative 12y on one side and the regular number, which is 8, on the other side. And what we're going to do is we're going to figure out a number to put over here that will make this into a perfect square binomial. I know it's going to look like this, something y with something squared. Okay, and I know the way I find that number is I take half of this number, so half of negative 12 is negative 6. That's what I'm putting over here. And I take that negative 6 and multiply it by itself. So negative 6 times negative 6 is plus 36. So the number that had to be added to make this into a perfect square expression was 36. Of course, that means I have to add the 36 to the other side as well. So now, as I said, I've rewritten this as y minus 6 squared, and I add the x and the 8 and the 36, and that gives me 44. And the next step is, once I have the binomial squared equaling a number, is to take the square root. So I get y minus 6 on the left side and plus or minus the square root of 44 on the right side. And it's not a perfect square, but I can simplify this into, this becomes the square root of 4 times the square root of 11. So this becomes plus or minus 2 radical 11. So we have our y minus 6 equaling plus or minus 2 radical 11. And now all I have to do is add 6 to both sides. so that my final answer comes out to be y equals 6. Remember, the number I bring on the other side is always just a regular number. I always want it first. 6 plus or minus 2 radical 11. I can leave it with this plus or minus because I'm not going to be able to combine them. The only time I actually separate it and do it is when, if this would have been just like, say, a 2, and the two numbers could have been combined. But here's your answer in what we call simplest radical form. Okay, as I put on the board, I have by this afternoon, you will see posted sometime after 2 your next test on Delta Math. It's called test number 2 for fall 2021. It's on Delta Math. This test is on Delta Math and it covers chapters 5 and 6. I gave you 2 chances on each problem, so you should be able to do that test. We'll continue with our study of quadratic equations on Tuesday. This is due by next Thursday.
How long do you have for the test?
What?
Time?
How
An
much-
hour?
It's 45 minutes. It's 10 questions. 45 minutes should be more than enough for you to complete it.
Okay, thank you.
Okay. Tashana, I knew you were here. So when I took attendance, I included you. Okay, have a good weekend, everybody. Do look out also, I hope I'll be able to find some homework on this, completing the square. If not, I won't give it to you, but definitely look for the test.
Okay, have a great weekend.
Have a good weekend, everybody.
Have a good weekend.
Bye-bye.